1.3.3 can expand a factorized expression by recognizing the difference of perfect squares. So the perfect squares is a pattern that develops when you can see when you've got a certain lineup of terms in brackets. The perfect squares pattern is when you can see that the brackets have something, which we'll call it A, minus something else, and then that same number plus the other one. Or it can be written the other way around. That's also fine. If you see brackets like this, there is a pattern, and a pattern can save you some time in being able to answer these questions. If you struggle to find the pattern, that's okay. You can just expand these as normal. So for example, this first one, m times m is m squared. M times negative 5 is negative 5m. Positive 5 times m is positive 5m. Positive 5 times negative 5 is negative 25. Collect the like terms. Negative 5m plus 5m. A lot of people struggle with this, but would be able to do the other way where I'm perfectly fine. If I have 5m's and I take away 5m's, I then have no m's. So the final answer is just m squared take away 25, because negative 5 plus 5 is 0. So the pattern that we've got here is, you see how these two brackets have got the same thing at the start, the same thing at the end. The only thing that's different is that in the middle there's a plus and a minus, while that means that the final answer will always be the first thing squared take away the second thing squared. So for example, in this one, the final answer will be the first thing squared take away the second thing squared. Minus 25c squared. Please be careful though. A lot of people see this pattern and think, oh, hooray, I don't need to expand brackets ever again. I just do this. And they get the questions wrong every time because they don't look for the crucial things, that there should be a plus and a minus that has to be different. And they need to make sure that the first thing are identical and that the second thing is identical as well. 1.3.4 can expand a factorized expression by recognizing the square of the binomial. This one also leads to a pattern. However, if you cannot recognize the pattern, it's worthwhile to make sure that you just expand as per normal. So I've got 9x plus 2 squared. When you see the squared on the outside, what that means is just to repeat the brackets accordingly. So 9x times 9x gets me 81x squared. 9x times positive 2 is going to make that positive 18x. Positive 2 times 9x is going to make that positive 18x. And positive 2 times positive 2 makes that positive 4. My final answer here is 81x squared plus, in this case, 18 plus 18 is 36x plus 4. Now there's a pattern here as well. So you might see here when I've got this squared here, if I have one thing plus another thing squared, then what that becomes is that the expanded answer is going to be a squared plus 2 times the first thing times the second thing plus the second thing squared. As you can see here, my final answer, 9x, 81x squared. So 9 squared, x squared. This 36, 2 times a times b, or 2 times 9x times 2. So 9 times 2 is 18, times 2 is 36. And then we see for the b squared here, and for this b squared here, that's going to be 2 squared, which you can see here is 4. There's also another alternative version of this when there's a minus, and this is the final pattern where there's a minus there instead. If these patterns, again, because you might not be able to memorize these and you might make a mistake, or you're feeling a bit unsure about these, don't worry, they're not compulsory. It's only there to help you out if you see the pattern and you can speed up with your answers. So here I've got 2 brackets x plus y squared. Well, that's the same as saying 2 x plus y, x plus y. Now this one I am feeling confident about doing the pattern. I'm leaving the 2 on the outside, and I'm just going to put these little square brackets in here so I don't get too confused, because I'm going to multiply everything by 2 at the very last step. So this is going to be x squared plus 2xy plus y squared, because I recognize the pattern. So my final answer is going to look like this.